we were going to do a bit of revision on the cubic function. This is something that we have done before in a course, but it's worth a lot of marks, and I really think that it's something that is worthwhile for us to go over. Okay, so the question that I've selected says to us that the graph of g of x equals ax cubed plus bx squared plus cx, a cubic function having y-intercept of 0, is drawn below. The x-coordinates of the turning points are -1 and 2. Okay, so we know the y-intercept and we know the x-coordinates at the turning points. The first thing that they're asking us is for which values of x will g increase? What does that mean? What are they asking us for here? What do they mean by the word increase? What does the word increase mean when we talk about functions? Okay, so the gradient, there we go. Well done, Kanisa. It's that part of the graph with a positive gradient. Okay, so the word increase specifically means positive. That's just an abbreviation for positive gradient. Okay, so in other words, if we were walking along here, we would be walking uphill. Okay, so where would we be walking uphill? Between which 2 points on the graph would we be walking uphill? Okay, well done, Kanisa, between -1 and 2. All right, so the portion of the function that you are referring to, Kanisa, is this bit over here. And quite right, that is actually indeed where we would be walking uphill. All right, so now how are we going to write that in the mathematically correct way? Oh, there we go, Spoosie. So you've put that down for us beautifully. Okay, so where x is greater than -1, but smaller than 2. So just tell me, Spoo, why didn't you include -1 and 2? What's the reason for excluding the -1 and the 2? What does LAG mean, Nick? Oh, maybe you're lagging. I don't know, maybe I'm lagging. Okay. So in other words, the question I'm asking you guys is this. Why are we writing where x is greater than 1 but smaller than 2? Why are we not doing this? Don't write this down.
Beyond the 100
So this is wrong. We're not going to write that down, but I'm asking why. Why would we not write it like that? Okay, because at -1 and 2, the gradient is not positive. Okay, the gradient is 0. So the gradient is 0 at -1, and the gradient is 0 at 2, and that's why we would not include those values. Okay, and for a question like that, you can't get part marks. So you can either get 2 or nothing. All right, so it has to be written like this. Or your alternative is to say x is an element from and use round brackets, smaller number on the left, larger number on the right, and then round brackets again because neither value are included. Okay, all right, let's have a look at question 8.2. Now they want the x-coordinate at the point of inflection. The x-coordinate at the point of inflection. I'm going to let you guys do that one. You do that, and then you tell me, well, Neliswa and I, what you've got as an answer. So the x-coordinate at the point of inflection. And as soon as you've got an answer, pop it into the chat. Okay, Spoo, so you've got 1/2 as your answer. All right, I agree with you. I got that same answer as well. How did you work that out, though? How do we get 1/2? So midpoint between where, Spoo? Or midpoint of what? Exactly. Okay, so what Spoo is referring to is, sure, okay, so in other words, what I'm trying to get you to say is this, Spoo, okay, you've got one turning point over here, and you've got another turning point over here, all right? And exactly halfway in between these two lies our point of inflection, okay? So in order to calculate the x coordinate at the point of inflection, we use midpoint formula, okay? So in other words, x equals -1 plus 2 all over 2, okay? And that's where we would get x equals 1/2 from, okay? Why do we have to do it this way in this case? Why is there no other way to do this here? What haven't they given us? Or what is, in fact, what I'm trying to ask you is, what is the other way that we calculate the x coordinate at the point of inflection? Can anybody tell me? There you go. Okay, well done, Kanisa. Your answer is perfect. Okay, it's because they did not give us any values of a, b, and c in the original function. So we can't find the second derivative in this case. But yes, Amanda, that's what we would also do, or we could also do. We would use the second derivative, but we can't do that in this particular case. Okay, so that means that we need to know how to be able to calculate the point of inflection using midpoint formula. Okay, all right, good. Let's carry on to the next question. For which values of x will g be concave down? Okay, so I'm going to wait for you guys to tell me what you think the answer to this is. For which values of x is the graph of g concave down? Anybody know where the graph stops being concave up and starts being concave down?
Ma'am.
Yes, Cabello.
I think it's from that point of inflection, that point P is to the other point of inflection going to the right.
Okay, so
Right.
you're on the right track, Cabello, but there's only one point of inflection in the graph. Okay, there isn't a second one, but you're quite right. So on this side over here, from the point of inflection onwards, now here where I'm sort of coloring it in this blue color, the graph is now concave down. All right, so in other words, you're quite right, Cabello, from this point onwards, okay, where x is equal to 1/2, it is now going to be concave down. All right, so the correct way to set that out is to say where x is greater than 1/2. Okay, and again, it's 2 marks for the answer only. There's no other way for us to write that, of course, unless we want to use interval notation, and then we could say from a half to positive infinity with round brackets. But the first method is so much easier. All right, now they say to us, if g prime x is minus 6x squared plus 6x plus 12, determine the equation of g. What does this mean? What do they ask? What are they asking us to calculate? If g prime x equals minus 6x squared plus 6x plus 12, what are they asking us to calculate? Sure, but exactly what in the original function, Kanisa and Naledi? Quite right, but what? Okay, elaborate a little bit, Kanisa. No, Nick, we know what the we know what the x coordinates at the turning points are. We don't know what the y coordinates are. There we go, Tsipiso. Okay, so the values of A and B and C in the original equation. Okay, so up here, let me just highlight it for you guys. All right, so over here, this is what they're after. Okay, so they want us to determine the equation of G. Here's the equation of G. So this is another way of them saying to us, we need to calculate the values of A and B and C in G of X. That's what they want from us. Okay, now, how are we going to do that from the derivative? What are your ideas? How would we work from the derivative and get the values of A and B and C? If you've got an idea, please share it with us in the chat. If you don't know, you're welcome to say you don't know as well. There's nothing wrong with that. That's why we're here.
Oh, it's episode posted. Oh, there.
By working backwards, absolutely, Tsepiso. So what are we going to do exactly here? When you say working backwards, what do you mean exactly? Yes, Minentle, you're welcome to unmute yourself and talk if you'd like to. Oh, you mean like that? Okay, all right. No, we don't have to take, because we've been given the derivative. Okay, so there is such a thing as working backwards from the derivative, but it's not part of our syllabus.
Yes, ma'am. I think it's going to be 12x plus 6.
Okay, but that's you finding the equation of the second derivative. Okay, so in other words, what you're doing here is you're applying the power rule to this. They want us to go back to the original equation. They're not asking us for the second derivative. They're asking us for the original cubic function. Does that make sense to everybody? Okay, so when they refer to the equation of G, they're talking about the original cubic function. Okay, so in other words, they want this A here and that B there and that C there. That's what they want from us. Okay, and what they've given us is the derivative. So we would say, okay, fine. The derivative that they've given us is minus 6x squared plus 6x plus 12.
Oh.
The only way that we can relate that to what they've given us is by us taking the derivative of this. So we are now going to apply the power rule to that. So g prime x equals So 3 times ax is going to give us 3ax, take 1 away, and that will give us squared, plus 2bx plus c. Does that make sense to everybody? Emoji, how do you feel? Does that make sense? Do you understand what I'm doing here? Sure. Okay. Oh, good. All right, lovely. Oh, that makes me that makes me happy. Okay, Panache, you've said please explain again. That's no problem at all. So Panache, over here, they've given us g of x, and they've told us that it is the graph ax cubed plus bx squared plus cx. So what I'm doing is I'm finding the first derivative, because that is what I've been given over here. And then I'm going to use inspection to help me solve my problem. So g prime x, so now I'm applying the power rule, Panache. So I'm multiplying the exponent by the coefficient, and then I'm taking 1 away from the exponent, okay? So that's how come I end up with 3ax squared. And again, you're going to multiply the exponent by the coefficient and take 1 away from the exponent. And again, take the exponent, multiply it by the coefficient, and take 1 away. Okay, that's where it comes from. Maya, did that help? So now what I can do, let's just see, did that help? Nolwazi says, fine. Okay, Panache. Let's just check. Maya, are you okay? Good, Panache. I'm glad you're feeling better about it. Okay, and then what we're going to do here is this. We're going to say this term over here is this one here. And this term over here is this one over there. And this term over here is that one over there. So we're using inspection. Oh, okay. All right. No problem, Maya. Okay. So we are using inspection. Okay. Now, is that something that you've used before at school, Matrix? Do you know what I mean when I say we are using inspection? Is that something that, a word that your maths teachers have used? Yes, no. Okay, Maya says no. Kanisa doesn't ring a bell. Bridget, yes. Yes, but you've forgotten. Eminem, no. Okay, all right. So there's a lot of very conflicting answers. All right. So they have given us the second derivative, and we have taken, sorry, they've given us the first derivative, and we have taken the first derivative. So what we now have is an expression for the first derivative with numbers in it, and an expression for the first derivative with letters in it. And it's now our job to equate these in order to be able to solve for our unknown. So in other words, we can see over here, we've got an x squared term, and here we've got an x squared term. All right, so that means that 3a has to be equal to -6. Okay, we're equating the coefficients of the same terms. And now we would divide the left by 3 and the right by 3. And a is going to end up being -2. Okay, all right. Menenhle and Silindile. Where did I lose you? I think it's probably more the concept rather than the actual maths. Where did I lose you? So if I can maybe just try and explain it again, all right. They are asking us to determine the original equation of G, all right, so the original cubic function, okay? But we don't know what these values are. It's our job to work out what this A over here is, and that B over there, and this C over here. They haven't given those to us. They want that from us, okay, when they ask us to find the original cubic function, all right? All they've given us is the derivative. Okay, so where does the derivative come from? Okay, so it comes from taking the original function and deriving it, doesn't it? Okay, so in other words, if they give us the original function is g of x, and they tell us that it is ax cubed plus bx squared plus cx, the first derivative is me applying the power rule to each of these terms. So I'm saying 3 times a is 3a, and then I'm taking 1 away. So we all know how to derive by now. Same story with the middle term. We're going to multiply our exponent by our coefficient and then take 1 away from our exponent. And same story with the last term. Okay, we're going to take 1 and multiply it by c, and we get c, and when we take 1 away from the 1, we end up with x to the power of 0, and that's why we've got g prime x equals 3ax squared plus 2bx plus c. Now, they've given us some important information about this graph, because they've told us that g prime x is the graph of minus 6x squared. Let's see what else they told us. Plus 6x plus 12. So in other words, they have told us that this term over here is this term. And this term over here is this term. They're the same. And this term over here is this term here. Okay, so what we have to do is we have to use inspection and work backwards. So in other words, what we do is this, is we say if 3ax squared equals minus 6x squared, what we can do is we can leave the x squareds off. And we can simply work with the coefficients. So in other words, 3a equals 6. Now I've got to divide both sides by 3. So a is going to be equal to 2. I'm going to do the same thing with the middle term. I'm just going to write in green. So I'm going to make 2bx equal to 6x, but I don't have to write the x's. I can leave the x's off. Okay, and I can just write 2b equals 6 because I'm equating those terms. And now I can divide both sides by 2, and b is going to be equal to 3. Oh, yes. Sorry. I beg your pardon. You're quite right, because this was negative, wasn't it? So that should be negative as well. Yes. Thank you. Thank you. Quite right. And then the last one, let's do that in blue. C is simply equal to 12. There is no calculating there. I did. I did, Timna. I did forget. Okay, so now we can go back and we can say, well, g of x is the graph of minus 2x cubed plus 3x squared plus 12x. Okay, so we've worked out the values of the a and the b and the c. Okay, so a is -2, b is 3, and c is 12. Okay, so what did you use if you didn't use inspection, Nick? What method did you use? You factorized backwards. Okay. I'm not 100% sure I understand how you did that. I'd love to see what you've written. Because, yeah, I mean, without the values of A, B, and C, yeah, I mean, you can't take, yeah, I suppose you could take out a highest common factor, but that's not going to help you. I don't know any other way of being able to answer this question myself. But just because, okay, you use G prime. Okay, I use G prime too and went back. Okay, all right. Well, maybe it's the same thing. Okay. All right, good job. So now we've worked out the values of A and B and C. Last question. Determine the equation of the tangent to G that has the maximum gradient. Write your answer in the form y equals mx plus c. All right, so in other words, what happens here is that the gradient we know is always changing. All right, so what we want to try and find out is that point on our function where we have our maximum gradient. All right, so does anybody know where the maximum gradient is on a cubic function? It's a more sort of difficult knowledge question. Okay, so does anybody know? Not at the turning point. At the turning point, the derivative is 0. So the gradient would be 0. So the maximum gradient is at the point of inflection. So that's where the gradient will be at a maximum. So if we now want to calculate what that maximum gradient is, we need to sub the x coordinate into what? What gives us an answer for gradient? Remember, gradient is the first derivative. Okay, the point of inflection is your second derivative, your measure of concavity. Absolutely. So G prime. Okay, so what we've got to do now, just clear some space for us here, is we need to go and sub a half, because that's where our point of inflection is, into G prime. Now remember, G prime was this thing over here. Here's G prime. So that's where we're subbing a half in. Okay, so G prime a half equals minus 6 times a half squared plus 6 times a half plus 12. Okay, and then we can pop that into our calculator and you guys can tell me what you get as an answer. There we go. Okay, so Kanisa, I got the same answer as you. That's it, Liam. Same thing. Yep, correct, Timna. Okay, so 13 and a half. Or if you want to write it as a improper fraction, it would be 27/2. Doesn't matter. Nothing wrong with that. Okay, so the equation of the tangent to G with a maximum gradient, so we found the maximum gradient, write your answer in the form y equals mx plus c. All right, so now we need to calculate, because remember, if we want the equation of a tangent, we need the gradient at the point of tangency, we need the x coordinates at the point of tangency, and we need the y coordinates of the point of tangency. So we've worked out what the gradient is at the point of tangency. That's 13,5. The x coordinate at the point of tangency is a half. How are we going to get the y coordinate at the point of tangency? Where do we get that from? Anybody know where we're going to get the y coordinate from? There we go. Well done, Leander. Perfect. Okay, so we sub back into the original form, the one that we've just calculated. Okay, so in other words, this one over here, I'm just going to put a ring around it for us, a pink ring. Okay, we've got to go and sub back in here because that's the equation of the cubic function. All right, so now, so g of a half is equal to -2 times a half cubed plus 3 times a half squared plus 12 times a half. And then you guys can share with me what you think that's it, Mulwazi. What do we get? Me too, Panache. I also got 6,5. Or some of you may choose to write it as 13/2. Okay, 6,5. All right, now, almost there with this question. They wanted us to determine the equation of the tangent. So if they're asking us to determine the equation of the tangent, what are we going to do with these 3 things? So these 3 things over here, what are we going to do with them so that we can find the equation of the tangent to the graph with a maximum gradient? Find C, absolutely. There we go. Well done, everybody. Okay, so we need to put all of this into y equals mx plus c. And of course, it's c that we need to find the answer to. All right, so we know that y is 6,5. We know that m is 13,5, and we know that x is a half, okay, or 0,5 plus c. So how big is c? Let's see what you guys get as an answer. Yeah, I used 27/4 minus 1/4. There we go. I get the same answer. Okay. Okay, so there we go. Y equals 13.5 x minus 0,25. Okay, good. So it should be negative null y. There we go. Okay, good job, everybody. Well done. Okay, should we go on to the next question? Are there any questions? Everybody happy with that? Okay. All right, let's have a look at the next question. Okay, now this is admittedly a little bit more difficult. How do you calculate the x and y intercepts of the cubic function? Okay, I can show you how to do that quickly if you like. Just move this down. Okay, so with this particular graph, it goes through the origin. So your y-intercept is going to be at 0, okay, because the graph is going through the origin. Okay, your x-intercepts, now I don't know if they will factorize nicely or not, because it's not something that was asked in this question. But if they ask you for the x-intercepts at of your graph, okay, so for your x-intercepts, you're going to let y be equal to 0. So you would take your original equation, the one that you've calculated. So in other words, this minus 2x cubed plus 3x squared plus 12x. And you would make it equal to 0. Okay. Now, the only thing that you can do here is to take out x as a highest common factor. Right? And I think what I might do here is take out negative x, because we've got this negative in front here. So this would give us 2x squared, not that it's really going to make any difference, minus 3x minus 4. Now that isn't going to factorize nicely. Okay, so we would have to use the quadratic formula. All right, so in other words, we're going to have irrational roots. Okay, it doesn't matter. So either x is equal to 0, which we know, or we're going to say x is equal to negative b. All right, so that's going to be equal to positive 3 plus or minus b squared. So it's going to be minus 3 squared minus 4. The value of a is 2, and the value of c is negative 4. All over 2a, which is 2 times 2. Oh, sorry. I'm being so stupid here. Sorry, guys. Thank you. I don't know. I was, for some reason, I was thinking 3 times 4 is 12. Okay, sorry. So this would be minus 12, wouldn't it? Hang on a second. Okay. All right. Now, I still don't know if that would factorize. Hang on a second. Just have a quick look and see if it factorizes nicely. Just give me 1 minute. Okay, no, it doesn't factorize nicely, so we would have to use the quadratic formula. Okay, my apologies. All right, so there we go. So what we would have to do now is go and sub this into the quadratic formula. So x equals negative b plus or minus b squared So that would be minus 3 squared minus 4ac all over 2a. Okay, oopsie, and then a needs to be 2. Okay, yes, Maya, ask a question. You're welcome to unmute.
Hello, ma'am.
Hello, Maya.
Hello, ma'am.
Hello.
How are you?
I'm fine. How are you?
I'm good, ma'am. I wanted to ask, how do we calculate coordinates in a cubic function?
Which coordinates are you talking about, Maya?
Ma'am, any actually, not the
Okay,
turning point. Not the
okay.
turning point.
So at the turning point, you have to use the first derivative.
Okay, ma'am.
Okay, so I don't have an example of that here, but I can find something quickly if you guys like.
Okay, ma'am, you can.
All right, just give me 1 second. I can find something here. Hold on a moment. Let me just have a look here. No.
Maya, is your question about coordinates?
Ma'am?
Is your question about coordinates in a cubic function or cubic equation?
In a function.
In a function, like the actual.
Yes, or a equation, like the actual, like.
That's why you use.
Ma'am, can I show you an example that I have here?
I don't know how you'll be able to show us. I mean, it's very difficult for me to see anything that you've got there.
Oh, yeah.
I think aren't you talking about when you have to factorize by inspection to find x values of the original cubic function?
No, I don't think it's that one.
Nalise, well, I don't know, I could, yes.
Like, okay, here another question that I have, it says like 9.1.1, it says show that B is equals to 1, C is equals to -16, and D is equals to 20 for 4 marks in a cubic graph. And then they give us G of X is equals to X cubed plus BX squared plus CX plus D.
Okay.
And then 9.1.2 says calculate the coordinates of P and R, which are turning points.
Okay, so is that what you're asking
this
about?
Graph. Yes, ma'am. But I also want to know if those points were not turning points, what was I going to use to calculate coordinates?
Well, you see, you would need to know you can't, because in order to calculate a coordinate, you either need a y coordinate and the equation and work back to the x, or they give you the x and the equation and you work out what the y is. All right, but
okay.
I'm sure, you know what, the only points that are of any significance, Maya, are the coordinates at the turning points and the x-intercepts. They shouldn't be asking you for any other points other than the point of inflection.
Okay, thank you, ma'am.
Okay, all right. Yeah, Ibrahim, I got the same answer. Let me just go back to where we were. Yeah, I got the same answer. Okay, so if they did ask us for the x-intercepts, that's how we would have to do it in this particular case. All right, and then the -1,81 would be this point over here. All right, and this one over here, that would be the +1. So that would be the 3,3,1. Okay, in this case. Okay. Are you guys all right with finding the coordinates at the turning point? Do you want me to go over that? How to find the coordinates at the turning points? Okay. No problem. All right, well, let's just work from this graph, okay? And let's say here, I'm just going to adapt this slightly for us because we know what the equation of this particular function is. So let's just work from this and go through that. Okay. All right, so just Erase a little bit more here. Okay, so for the coordinates, at the turning points, okay, we have to use the first derivative. Okay, and the reason that we use the first derivative is because the gradient at the turning point is 0. Okay, so now here we know that this graph is the graph of g of x. So it's g of x equals negative 2x cubed plus 3x squared plus 12x. So what we're going to do is we're going to take the first derivative using the power rule. So g prime x. We're going to apply our power rule to every term. So 3 times negative 2 gives us negative 6x squared. 2 times 3 gives us 6x, and 1 times 12 gives us 12. Okay, so the first derivative. Very important, you have to show that the gradient at the turning points is 0. You must write this 0 over here that I'm making darker. Okay, very important that you show that step. And then what we're going to do is we're going to write, so I'm just clearing some more space for us here. We are going to write our answer of minus 6x squared plus 6x plus 12. Now we need to factorize this, okay, because we've got 2 turning points. Exactly, divide through by negative 6. So this is going to end up being x squared minus x minus 2. We've divided every single term in the equation by minus 6 after making it equal to 0. And now we've got to factorize. Okay, so in one bracket, we've got an x. In the other bracket, we've got an x. One bracket, we're going to have a 2. The other bracket, we're going to have a 1. We want a negative 1 in the middle, so it's going to have to be like that. There we go. So yes, quite right, Nick. So either x is equal to negative 1 or x is equal to 2. Okay, very nice. And now when you want to find the corresponding y coordinates at those turning points, what do you do? How do we find the corresponding sub back? Absolutely. You guys do that. Sub back in and tell me what the coordinates at the turning points are. If it's necessary to do so, Katuano, sometimes it's not possible, but if it is possible to divide through by that first coefficient and then work with a positive x squared term, it just makes life easier for us. Or if this scares you, use the quadratic formula. Okay, so at this point over here, you can use the quadratic formula as well. Excuse me. Sorry. Yeah, only if it's a factor of all the terms. Thank you, Nolwazi. Okay, so Nick got negative 7. Let's just have a look. Okay, so we are calculating g of negative 1. So we're going to take negative 2 and sub in negative 1 and cube it. Plus 3 times negative 1 and square it. Plus 12 times negative 1 and work out our answer. Sorry, guys. I don't know what has tickled my throat like this. Minus 2 times 2 cubed. Okay. Okay, so we're getting -7 and 20. Okay. So the coordinates that were -1 and -7, that has to be a point that is in the third quadrant. There we go. Okay, here, -1 and -7. So that looks good. This point up here has to be in the first quadrant. Okay, and it looks quite high up. So I think those answers that we got of 2 and 20 seems reasonable here as well. Okay, so 2 and 20 up there. All right. Good. Well done, everybody. That's great work. Okay. Are there any last questions that you'd like to ask before we end off today? So there is a quiz tonight.
Yes.
If you guys have got time before the exam tomorrow. So big warm welcome, and well, not welcome, well done to everybody for doing so well, and all the very best for tomorrow.
How long does it normally take for one to complete the quiz? Is it like 10 minutes or more?
Pleasure, Bridget. All the very best. Okay, so remember, Matrix, as far as tomorrow is concerned, make sure that you read the questions properly and do the things that you know how to do first. All right, Nelisba and I will be thinking about you and crossing fingers and hoping all goes well. Okay, so Kutluano, you've asked a question. How do you find the equation of the graph from the x-intercepts of the graph? Okay, Kutluano, then you have to use this formula. Y equals x minus x1, x minus x2, x minus x3. And then you're going to sub the intercepts in here and here and here. And then you need another point, okay, another x and y coordinate. And you're going to sub that in there. Oh, sorry, I forgot off the A. Silly me. And then you're going to work out the value. Whoopsie daisy. Let me just do this. And then what you would do here is you would work out what that A value is. Okay, and then you would go back and go and sub it in and multiply all those brackets out. Okay. Right, so Pabalo, that's where you have to use inspection. Or it depends on what your teachers taught you at school. So if they've taught you how to do it by inspection or by long division or by, there's another method with a line. I can't remember what it's called. Okay, but yeah, you would need to use factor theorem if you didn't know what a factor was, and then work backwards. Yeah, starts with an S. I can't think of what it's called now. Yes, that's it. Well done, guys. That's it, synthetic division. There we go. Thank you, Amanda. All right.